All right, guys, in today's video, we're going to be taking a look at a broken gear on this electric motor drive shaft. I'm going to put it under the magnifier here just so it's a little bit easier to see. What we've got is a hairline crack right where you see that dark mark, and that's caused the shaft to turn and the gear slipping now. This is a friction fit type of gear. And so what we want to do is we want to replicate this, and so today I'm going to show you how you can create a 3D model in FreeCAD that we can use to create a mold to replicate this little gear, this guy right here. He's under too much torque from the motor to 3D print, but we can 3D print a mold, and we can pour a liquid urethane resin, and that'll be a suitable strength material. So to do something like this, we're going to take some measurements over to FreeCAD. So first thing we're going to do is we're going to need to know the diameter of this shaft. And by the way, this would apply to this little gear, or even if I was doing this really big one. So the first thing we're going to do is we're going to come in here, we're going to zero our tool out, and we're going to get a measurement of this shaft, which should be around, 2 millimeters for the shaft. Then we're going to come up here with this little gear and count the teeth. Now on one like this, it's pretty easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. But whatever you've got, if you got one like this, it's going to be a little bit more difficult to count. But you need to count the teeth. That's one of the things we need to take over to FreeCAD. The other thing we need to measure is the height of this gear. So again, we're going to zero our tool out, and we're going to measure the height of this gear. It looks like right around 5 millimeters. This particular tool has a habit of getting a little bit off on me, but I'm going to go ahead and call that 5 millimeters here. And then the next measurement I'm going to need is the width. Now this is going to be kind of off because of the crack, so we're going to want to squeeze this guy. And if we look at this, we can see this particular gear has got a design where the teeth don't go all the way through. There's like this little cylindrical ring at the bottom. Not every gear is like this. This is like a spacer. In this case, we'll measure that. It's just under 5.4. And I think with the crack we've got going there, if I squeeze it a little bit and you take a different measurement, that's the problem with something that's broken, is it flexes. I'm going to call that 5.4. So now we've got the height, we've got the gear count, we've got the size of the hole for the shaft. We can see on the bottom here, if we zoom in a little bit, I don't know if you guys can catch this, but there's actually a little chamfer cut in where the hole goes. And since we're going to cast mold this, we can capture that as well. It's very, very small. It's less than 1/2 millimeter of a chamfer, maybe 1/4 millimeter. So I'll show you in FreeCAD how we can capture that as well. The last thing we'll need to take over to FreeCAD is if we look at these teeth. These are really small, but I get it against my finger so it's on a darker background. The teeth kind of go up and over. There's like an angle to the cut. There's an angle to the cut, like a pitch to it. That's called the module. And we're going to need to know what that is. Now this is really going to be hard to do with such a small gear, but if we kind of estimate this, I'm going to say it's like 1/2. Just going to guess that this little piece here is like 1/2. When we get into FreeCAD, I'll show you what we're talking about here. And then the hope is that we can quickly cast a replacement. We can freeze the shaft. We can put the replicated gear in some boiling water. We'll be able to press fit it back on there, and we'll be back in business within 48 hours versus the time it would take us to order a replacement gear. So let's head over to FreeCAD, plug all this data in, and get a model. All right, guys, we're sitting here in Windows. We could just as easily have been sitting here in Mac OS. And we're using FreeCAD 1.0.2. It's available for both operating systems. I've got another application here in the back that we'll use to test the model when we're done. But let's just go ahead and get started. I'm going to get rid of this welcome to FreeCAD thing and this little piece here so that we're all clean. Leave this model and task view, though. Don't X this out. So getting in and out as fast as we can, we're going to create a new empty document. Once we have that, we're going to create a new part. Once we have our part, we're going to create a new body for the part. Once we have the body, we're going to go into part design, and we're going to pick the involute gear function. And this is where the heart of this whole FreeCAD software is. And we only need two values: the number of teeth that we physically counted on the gear. And then remember, I was mentioning about the module, which is like this pitch angle on the teeth. And we guesstimated ours at 0.5 millimeter. And I recommend that you type the way I'm typing here rather than selecting all this and then trying to zero it out, because for whatever reason, this involute gear feature, both on Mac and Windows, in my experience, if there's a value that is not greater than 0 in here, the app will crash. So just to try to avoid that, you'll get like a pop-up, a divide by 0 kind of error. All right, hit OK. And now we've got a two-dimensional representation of the gear. We're going to make sure the gear is selected, and now we want to make it three-dimensional. So we're going to extrude out the height. We're going to use the pad function for that. We measured our gear as 5 millimeters in height. So when it looks at this length parameter for the dimension, we're going to enter 5 millimeters and then hit OK again. Now in the Windows version, I'm going to tap this field and use the down arrow key to bring this into view. The Mac version is a different key sequence, but just to get it where we can see it. And so if we just had a simple gear, we're ready to drill the hole and be done with it. But our particular one had a section at the bottom where the teeth did not cut all the way through, if you recall. So we're going to add that attribute now. So I'm going to go back into part design for this gear, and I'm going to create an additive primitive in the form of a cylinder. Now, we measured the diameter at 5.4 millimeters on this particular gear, so the radius is going to be half that, or 2.7. And we measured the height of this cylindrical portion of this gear as roughly 1.4 of the overall 5. And with just those two parameters, we're going to hit OK. And we're kind of getting there. But what we can see is our teeth are sticking out too far. So we know this module is off slightly, like I was telling you it might be. So we're going to go back into the gear by double-clicking on it. And we're going to tweak this value. And again, without having it go to 0, I'm going to try 4.9 here. Probably could even do 4.95. I'm going to hit OK, and we should see this disappear. And it did. So now we've trimmed that up. So now let's get the hole for the shaft drilled. So our shaft was roughly 2 millimeters. So we're going to click on the surface of this guy here, of this gear. And I clicked on it again by mistake. Sorry about that. You only want to click on it once or it'll select the whole thing. Then we're going to do Create Sketch. And it's going to give us kind of this XY coordinate. And then we're going to take this type of sketch. Is going to be create a circle by center. And then we're going to go dead center here with the little crosshair. And we're going to make this hole be just shy of 2 millimeters so that we have a friction fit. So let's say, like 1.7. And then close this. All right, so now we've got this hole here with the sketch. Now with that sketch selected, we need to drill this out. So we're going to drill this out using the hole function. So you can click on the hole function. Here's another, problem with the code. But again, free software, right? You're going to have to deal with some of this kind of stuff. I just ignore all of these things. You want to set the depth to be through all. We want the hole drilled through the whole thing. Now, unfortunately, this hole parameter module doesn't pick up the diameter of the circle that we drew in the sketch. So we're going to have to type that in again as a diameter, 1.97 millimeters. But we can leave everything else defaulted and hit OK. And now we've got our hole drilled through it. It's still complaining about something. I'm just going to cross that out again. It's just how it is in this 1.02 version. I see more errors on the Windows version than the Mac version, to be honest. And now we're really roughly done here. If we were just going to try to 3D print a larger gear in nylon, we could be done. But the smaller one, since we're using it to make a mold, we're going to capture that feature we had at the bottom where it was chamfered. So we're going to go back to part design after selecting that, and we're going to apply a dress-up feature of a chamfer. And it looked like it was about 1/4 of a millimeter, but we'll go 0.3. Hit OK. And now we are done. We've got this part that I showed you earlier completely modeled in just a couple of minutes. So now we want to export this. Now, making sure that the body is selected. Don't just get one of the individual parts. We want the body, and we want to get all of these pieces and components in there. Then we can come up to File, Export. And the default is 3MF. But if you go in here, some software wants IGES, some might want Step C. It depends on what you're using. I'm going to leave it at 3MF, and then I'm just going to say small gear as our file name, and we're going to save that to the desktop. And there it is right there. So now I want to test this. Now, in Windows, I can see the hole in the icon that was used. The icon was created from the 3D model, as you can see. But I want to make sure that's actually there. So I'm going to come over to this software, which is 3D Viewer, which is a Microsoft app. And it's free in the Microsoft App Store. And I'm going to open this 3MF file. And I'm going to make doubly sure that the hole and the chamfering and everything that I expect to be here is as I expect it. Sometimes what you'll get is the hole will be missing, and that usually is because all of this componentry wasn't in the selection for the export. So that's why I like to physically click on the body in the model view here before I do the file export. And then I also like to test the model. If you're using Mac OS, you find an app in the Mac OS App Store, or there's a couple of free online 3D viewers that you can use to test that you have this right before you pull it into your slicer software for the 3D printer in order to make the reverse image of this, which will be the mold so that we can pour the resin. Like we discussed earlier, in this particular example, this gear is too small for its application, needing high torque and high RPM on an electric motor. It cannot be printed. It cannot be 3D printed. A 3D resin printer, the resin material will be too fragile and will disintegrate, and a filament printer will not hold up to the torque. So in both cases, we're better off just using a 3D printer to make the mold and pouring a resin that's more accurate representation of the original injection molding that was done on the part to begin with that we're dealing with. But if you have a larger gear, then it would be suitable for you to 3D print that with the appropriate filament type of plastic. So I hope this helps you out on how to quickly get in and do what you need to do here without having to learn a whole lot about FreeCAD or having to pay money for something that's a commercial product and be able to try to get this repaired. If you got questions or comments about specifically what I've shown in this video, go ahead and leave them down below in the comment area and I'll try to help. If this did help you, save you some time, I'd appreciate you paying it forward by hitting that like button. And as always, thanks for watching.